So we start 4.0 day 3, graphing linear functions using a table. We have to kind of remember, we've done a lot of stuff already this unit. We talked about domain and range. Remember our x values and our y values. We talked about yesterday, we did all that function notation stuff. Today, kind of similar, but kind of also different. All of these topics are fair game for your quiz on Friday, so please don't forget about the stuff that we talked about already this week. Any function can be graphed using a table of x and y values. This year, we will graph linear, absolute value, quadratic, and exponential functions. Can we all see? The sun just went out, sorry. A linear functions graph follows a straight line. There are two parts that we really focus on with these graphs, okay? The first one is the x-intercept. It is where my graph crosses the x-axis. Right here is my x-axis. Here is where it crosses. That's my x-intercept. The value of the y value, so if we think of this as a point, we'll have x is some number, y is always 0. So the y value at the x-intercept is always 0. That's because y moves us up and down, and if we are on that x-axis, we have neither moved up nor down. So it's just at 0. Questions on that? Similarly, we have the y-intercept. That is where my graph crosses the y-axis. And the x value at the y-intercept is always 0. So our coordinate would look like 0, comma, some y value. That's telling me I'm staying right in the middle. I'm not moving left or right at all. My x value is 0, but I am going up or down some amount. Questions on that? Okay, so here's what we're going to do. We are going to be graphing these functions. So the same kind of functions that we've seen. This one is f of x equals negative 3x minus 2. When we graph a function, we are always going to need 5 points. And I'm going to write that down in a second. You will most likely have a table like this already drawn for you, which is nice. You don't have to draw it, but it has 5 rows for 5 points. What we have here is literally like a table of x and y values, or a table of inputs and outputs. Remember, the x values represent our inputs. That's like our domains. Our f of x values represent our outputs. That's like our range. And then in the middle, we have to put it through the function machine, which this is the function machine that we are using, f of x equals negative 3x minus 2. We're going to plug our inputs into that thing, and we are going to get out an output. That's what we're doing here. So 5 points. The number 1 point that we want, because I want the line that I'm about to draw to be centered on this graph, is I'm going to pick my middle point to be 0. So right in the middle of our table, our first x value always is 0. Now I want 2 values that are bigger than 0 and 2 values that are smaller than 0. I always say, make our lives easier, pick some easy values. So I would always go with 1, 2, negative 1, negative 2. Those are the easiest things for me to plug in. You can really pick whatever you want. However, these values will be correct every single time if you do these 5 values. 0's in the middle, 2 bigger, 2 smaller. Now what we're going to do is we're going to plug these numbers in to our function machine in green there. So it says f of x. So I want f when x is negative 2 equals negative 3 times negative 2 minus 2. At minimum, this is what I want to see, the plugging in step. If from this step you want to go ahead and put this into your calculator and calculate it, or if you want to do the mental math and just figure out what the output is, that's fine by me. I like to do a couple steps in here. So negative 3 times negative 2 is 6. 6 minus 2, my output is 4. Negative 3 times negative 2 is 6. 6 minus 2 is 4. Every row in this table now represents a point that we can put on our graph. So I can now plot the point negative 2, 4 on my graph. And we are literally just going to do this, plug them in, show our work in the center until we get our 5 points. So go ahead and start working through these. I'm going to do the next one. F, when x is negative 1, I plug it in. Negative 3 times negative 1 minus 2. A little simplification. 3 minus 2, our output is 1. Keep going. So we should have now 5 points, and we can put those 5 points on my graph. All right, draw your nice straight lines through your 5 points. Your lines should have arrows on the ends. Everybody with me? Fantastic. 2 more parts that we have to do to complete this problem. Number 1, I have to figure out the y-intercept. Guess what? The y-intercept should be a freebie for us every single time if we did this right, because the y-intercept is where the graph passes through the y-axis. The x value at the y-intercept is 0. Do we know what the y-intercept is when the x value is 0? It should be right in the middle of our table every single time if we did it correctly. So this y-intercept is kind of a freebie for us. Let's write it as a coordinate. It should be 0, negative 2. Freebie. You don't have to do any work to get that. Now, sometimes we can look at our graph and get the x-intercept. However, take a look at this graph. By looking at this, is it going to zoom in? By looking at this graph, we see that line is kind of going through the middle of a box. I'm not going to eyeball this. I'm going to actually figure out what this point is. The easiest way to do that, it says the x-intercept is where the graph passes through the x-axis. The y value at the x-intercept is always 0. Do we have a y in this function? We learned function notation yesterday. We said y equals is for babies. What did we replace y equals with? F of x. F of x is the same exact thing as our y value. So I'm going to replace that y value with 0, right? Because when the y value is 0, that's where we get our x value for our x-axis. So let's take this. Let's do our x-intercept. Our equation is f of x equals negative 3x minus 2. I'm going to plug in 0 for f of x, negative 3x minus 2, and I'm going to solve for x. Am I going too fast, or do we understand what's going on? So our x value is negative 2/3 for our x-intercept. Make yourself a note. Plug in 0 for f of x. Don't try to eyeball this by looking at the graph. Any questions on this? Okay, let's do one a little bit faster. Yeah, can we do that? Turn over to the next page. That's so great. What 5 points do we pick for our x values? Anybody? 5 points for my x values. Adriana. Perfect. Make sure 0 is in the middle. If 0 is not in the middle, you're going to get thrown off. Then I'm going to plug these values into my equation. F of x equals 2x plus 1. We can write it out. All I require for you to have written out is the step where you've plugged it in. If the rest you want to do some mental math for, that's fine. Or calculator math. So this is negative 4 plus 1, aka negative 3. Go ahead and fill these out. This isn't like hard math, right? Like it's easy. It's just a little bit time consuming. Is that how we're all feeling right now? Okay. Once we get 5 points, we plot them on our graph. And we use our ruler to draw a straight line. Arrows on the ends. Look up when you got it. Okay. X-intercept, Y-intercept. What's our freebie? The what? What is our freebie? X-intercept or Y-intercept? The Y-intercept, where does it come from? The middle. So our Y-intercept is right here. It's 0, 1. How do we find our X-intercept? 4. We plug in 0 for f of x. So 0 equals 2x plus 1. We're solving for x. I'm running out of room. X equals negative 1/2. So that should be negative 1/2, comma 0. Beautiful. Any questions on this? Okay, I'm going to shake up your world a second here. We're going to do one more, and then I'll leave you alone. Look at C. I know. Okay, so we see in C, 2/3 x minus 1. Think about the values that I plugged in for x here. If I do 2/3 times 2, I'm going to get a gross fraction. If I do any of these times 2 or times 2/3, I'm getting gross fractions. So these are not the points that we have to pick. These are just usually the easiest points. I can pick points that make my life easier and get rid of fractions. In fact, I really recommend you do, because if you're trying to graph fractions, you're going to get messed up. So if I put 0 in the middle, like I should always be putting 0 in the middle, what should I count by instead of counting by ones to get rid of that fraction 2/3, James? 3. How do you know it's 3? because the denominator is 3. So if I'm multiplying 2/3 by anything that's a multiple of 3, it'll get rid of that fraction. So instead of 0, 1, 2, let's go 0, 3, 6, -3, -6. Watch how that makes my points nice whole numbers here. F of -6 equals 2/3 times -6 minus 1. 2/3 times -6 is -4 minus 1. That's a -5. I'm going fast here, sorry. 2/3 times -3 is a -2. Minus 1 is a -3. 2/3 times 0 is 0 minus 1. That's a -1. 2/3 times 3 is 2 minus 1. That's 1. 2/3 times 6 is 4 minus 1. That's 3. 5 points. They should all now fall on nice, even numbers, right? Nice corners. Oh, I did not put that in the right spot. Oopsies. -6, -5. -3, -3. Perfect. Okay. Y-intercept, x-intercept, what's our freebie? In the middle. Is this our y-intercept or our x-intercept? Y. How do we get our x-intercept? Ooh. Plug in 0 for our f of x. So 0 equals 2/3 x minus 1. We add 1 to both sides. We're dividing by 2/3, which is the same thing as multiplying by the reciprocal 3/2. So x equals 3/2. Any questions there? For letter D, what would I count by if I wanted to make nice whole numbers? I would count by 4 because I'm looking at the denominator.